So Ghanshyam sir, shall we start? Because people are joining slowly.
Yeah.
So that, now it has clocked up to 45 participants.
Right, sir.
So we'll start now. So hopefully they will join in the meanwhile. Okay.
Am I audible?
Yes, sir. Just I will give a small introduction, sir.
Right, sir.
So Nitin sir is available with you?
Yeah.
Good morning to one and all present here. It is with great pleasure and honor to welcome Feast Engineering Online Mumbai, who is also a technical partner to this 6-day event. To all participants, I would like to introduce a small brief introduction about Feast Engineering Online. They are an incubator of IIT Bombay, and they have been affiliated with the AICT NEET portal also, and where they are specialized in creation of modules for engineering teaching. We at SRM has personally witnessed their technical prowess of their contents. In order to share the joy of learning through AR VR, we have included a session in our FDP program also. I request all the faculties to witness their developments in the field of AR VR. Let us all embrace this new technology, as this may be included as a new age teaching in the near future. Today, our resource persons are Mr. Nitin Bhatt, Director, Feast Engineering Online, and Mr. Ghanshyam Varke, Senior Manager, Feast Engineering Online, Mumbai. Thank you, sir. I'll hand over the session to you. You can continue, sir.
Thank you. Thank you very much, sir.
Thank you, sir.
Good morning to all. This is Nitin Bhatt. Without losing much time, I think Yoganand sir has given the introduction. So we will not spend much time on introduction, and I'll hand over to Ghanshyam to take it forward and show you the developments in the better learning and better teaching with the help of augmented reality and virtual reality. Ghanshyam.
Yeah. Thank you, sir. And good morning to all. And first of all, thank all of you to take the time from your busy schedule. And thank SRM University, Yoganand sir and team for giving us an opportunity to participate or to support this faculty development program for the awareness of the latest tools and technology, which will be included in the future in our academia. So, like this is our today's agenda. Like I will give you a few lines about free software and from where we have started and what we are doing today, and what is the way forward, keeping in mind academia and industry altogether. Then next point would be about metaverse, the upcoming trends. Then how we should change our teaching pedagogy as far as the engineering field is concerned to get acquainted with this new trend, metaverse. Then next would be what is augmented reality, virtual reality, that means hardware wise, functioning wise, development wise, and what is the difference between that? So that we will try to understand first. So most of you may be knowing this term, but we will try to go deep into that. And then few activities what we are doing ourselves and along with other institutions, like from V lab towards VR lab, that means virtual lab to virtual reality lab. Okay. So that's what we have taken initiative. Then sixth point would be the use of AR, VR in academia with some demonstration. So I am having that VR equipment with me. here, and I will try to show you some live applications, and you will be able to see it through the screen. Then I will also highlight a few industrial applications, because just being theoretical or academic side may not suffice for the students. And, ultimately, the students are going to join in industry after their final semester. And I have a question answer at the last, but I would urge in between, if you have any question and answer, that is questions, so I'll be happy to answer that there itself. So that at the end of the session, you may not remember that particular question. So wherever I am there in the presentation, you all are welcome to ask your doubts or questions there itself. Now, I will take a run through in few slides from about our company. Like this is a little bit of IIT Bombay, and our main business is using the futuristic tools and technology to upgrade the entire team pedagogy. And like Sir said, engineering online portal is being evaluated or weighted by AICT lead, and courses are commercially available for individual use or as an institution on the AICT website also. So I have given that link also here. Or even you can search into Google NEET AICT /ENGG online. Then you will be able to jump on that page. So in short, we have various solutions. So I have just segregated that in different boxes in front of me. Like first one, ENGG online portal. Okay, so I think one query is there. Mr. Francis. Yeah, Mr. Francis. Miss Francis. Right.
There is a question coming, I suppose.
PPT was not clear sometimes. It was blurred like that shown.
Yeah.
Ma'am, it depends on your internet connection speed.
Okay, fine. Okay.
I think
Right.
for others it's
Fine.
clear. Maybe.
Okay,
But
thank you.
if you don't understand or not able to see, just ask me. So I will be able to explain at least orally. So ENGG online portal, that is one of the vertical whereby we are creating the courses. But how these courses will be different from the resources which are available, like NPTEL or many YouTube videos or your own content, faculty content. So most of the content which is available may not be mapped to particular university, or even if it is mapped to particular university, then for other university to university, the topics or the teaching methodology may change, which may not be customizable. So in other portal case, the situation is whatever is available, you can take that as per your requirement. But here in ENGG online portal, we have mapped it to AICT curriculum, and say around all universities are following the AICT curriculum, which is maybe say in the range of 70 to 90% of what curriculum they are having, and the rest of the content we are trying to customize as per the requirement of the particular university. And also we take the continuous feedback from the faculty and students, and we are trying to incorporate maximum feedback ongoing basis. So it is not a one-time solution what you will be getting, but there is a continuous upgradation in that. And these courses or whatever solutions, all things we are offering, these are very standard. So then we also have the design calculation models for mechanical and civil engineering. So majorly design of different mechanical components like gear, shaft, bearing, more than 100 components are there, and few components from civil engineering. So this is the part which we started long back, the decade back, and now we are focusing to the ongoing trends like VR, AR, and engineering online courses. And we are also trying to get associated with few premier institutes and creating virtual that means from V lab to VR lab. That is the concept, gamification part. So I will just go a little bit forward. So the world is moving to the metaverse now. So everyone is discussing about the metaverse, Facebook, then cryptocurrency, blockchain, mining, data mining. So these are the few hot terms which are being discussed day in and day out as of today. So what is metaverse? So most of you may be having idea that Facebook has changed their branding from Facebook to Meta, and they are launching this metaverse. So most of you may be knowing or may not be knowing, but I will just like to highlight few lines because ultimately whatever technology or the trend what we are trying to implement in our day-to-day.
Ghanshyam sir, sorry
Yes,
to interrupt. We could find something blurred actually on the top of your screen.
okay. Just a moment.
And this blurring is happening throughout the screen right now.
Okay, so let me reshare the screen.
Ah, yes, sir. Sure.
I think this is a toolbar from Zoom. Anyway, is it clear? I think there is a bar at the bottom.
Okay, it looks like your toolbar, right, sir?
But rest of the screen is clear.
Rest of the screen is clear, sir, but in the middle of your presentation, it is look like something disturbing.
Give me a moment.
So, so now it is okay, fine. But to the screen at the bottom,
Is clear now?
Now it's clear, right? Yeah. Yes. Okay. So I will just continue what I was saying that ultimately what technology we are going to use as of today, AR and VR, and the way we are teaching because pandemic has taught us lot many things. Like only a physical classroom may not be a solution. So So metaverse. So what is metaverse? They are trying to do. They are trying to mimic our physical world into a virtual one. So like we explore the Google Maps or Google Earth. So it is all about getting seeing the satellite view as actual. Okay. So the same thing, what they are doing, they are trying to mimic the real world objects, places, or built in that virtually. So like you have heard about lot many news that there is a virtual land selling, Nana land, this center land into metaverse for millions of rupees. So why people are that means buying or selling the land virtually? Because what is happening in metaverse, they are trying to blur the line between physical world and the virtual world. So how that can be done? So they are saying that everyone is having the smartphone with them, right? So the screen timing during this pandemic for the smartphone was around say 10 to 12 hours or more than that. Now everything is going back to normal. Now how to get uh, end users engaged in some immersive activity whereby they will be using more of the screen time. So that's how they are creating this virtual reality as a metaverse. So here what is happening, everyone will be wearing this lens here. So this is the lens with the controller. So this lens is by Facebook. So this is called virtual reality headset. Whereby if we wear this headset, we will be in some different world, which is being created by the developers. So it may be our institution, it may be our office, it may be Google Earth or any part of the world which can be created over here. Now, how we are going to use this metaverse? So obviously we have to log in through Facebook. So we need to have a Facebook login. After logging in, we will be creating our avatar. So I'm just giving you the background about metaverse. So whatever I'm telling in metaverse, it is not that complicated when we are trying to implement the virtual reality system in our day-to-day teaching. It will be quite easier. But this is the feature which will be going forward after 3 to 4 years. So everybody will be doing the same activity what I am mentioning right now. So for that purpose, I am just explaining a little bit before coming to our actual use of AR and VR. So this is a trend whereby everybody will be wearing this headset in the morning till night, and we can do a lot of activities over here. Like our avatar will be there; he will be having similar face of the individual who is having this particular lens. So facial expression will be also captured over here, and this avatar will be given some free clothes and virtual clothes and accessories. So the commercial part would be purchase of different this thing accessories for the avatar and different assets. Okay, so that can be done through this cryptocurrency. That is what is being proposed. So that's how these terms are or technology is under very much demand. And this avatar can go to different places, like say a marketplace, or it may be a institutional, or it may be a mall, anything. So the entry may not be free. So that's how this whatever the land, like say for example, one builder who is purchasing this virtual land, he may sell it to different customers. So customer may be a mall, shopping mall, or it may be a playground, or it may be a institution also. Like for example, SRM University or any other college, whereby they want to have a virtual presence in a metaverse, because everybody will be having this lens, students and faculty as well. And there we will be creating virtual assets like virtual university. Like we are sitting in this say conference room or in a lab. So same setup can be created into virtual reality, and that is the future. Because right now what is happening, the metaverse is being used by or used for like say gaming activities majorly, then other recreational activities and some gambling. But in future, everybody will be on metaverse because right now Nike and a lot many other brands they are going on virtual mode. So they have created a shop, virtual shop, whereby we can do a shopping virtually and we can get those assets to be wear by our avatar in metaverse. So this is the ecosystem. So metaverse is by Facebook. So similarly, Microsoft, IBM, they are trying to create different what we can say verses like Omniverse is there. Uh, then different types of names would be there in that. Yeah. So this is a future trend which will be coming up, and now the question will be how to get ready for that. So we need to change our pedagogy as far as what we are teaching or learning or in current infrastructure as of today. So the teaching or the learning pedagogy should be to empower the tutors or trainers with AR, VR enabled tools as per their model curriculum. So here, even if we are using this latest trends, so one thing is very sure that syllabus cannot be replaced or it cannot be omitted, faculty cannot be omitted, and various our processes like lab experiments and all these things, or even physical practicals, those cannot be avoided. So this is what we can say, just making the student virtually engineer. But we need to have a practice physically also to some extent, though the ratio may change, virtual practical and physical practical in labs or in industry. So that is must. So here what is happening, the pedagogy should be to support this curriculum. Plus, we have to build immersive content which can be used on daily basis for teaching and learning. So it should not be only a wow effect or like a gaming kind of environment. So after using it for some time, everyone getting bored, or it may not be useful, or it may not be aligned to our outcome-based education system. So pedagogy should be aligned with that. Though, so you can just say in layman terms, like for teaching, we are using different tools as of today. It may be a textbook, it may be a PPT, it may be a YouTube video, it may be any other online or offline resource. So we are just adding one aspect of that, which is the AR and VR. So it is a teaching aid or learning aid. It is not replacement to any existing methodology. Now coming to the point, what is the virtual reality, augmented reality, the difference between that. So on the screen you can see on the left hand side, so few lines I have written about virtual reality. So here before going to that definition, so what is the hardware or what are the tools required to experience this virtual reality? So the first component would be the gaming laptop or computer, which we can say desktop, then head mounted display and sensor and controllers. So I hope everybody is able to see what is in my hand. So this is the head mounted display along with this controllers. So the name of this head mounted display is Oculus Quest 2 or Meta Quest 2 by Facebook. So I will come to hardware a little bit in detail. after explaining the difference between AR and VR. So here in virtual reality, what is happening? I will start my video. If I put it on my eyes, so I will be in some different environment. So I am experiencing virtual world, which I am feeling as a I am there in a reality. So that's how the term is virtual reality. The world is virtual, but I am feeling 99% real. I can interact with the object, like smallest washer, not any biggest object, I can interact. That interactivity is there, and if I turn around anywhere, so I will find immersed in that particular environment. So that virtual environment, I am feeling reality. So that's how the name is virtual reality. Now the next one is the augmented reality. So augmented reality is that means it can be experienced using this particular tool set. First, you need mobile handset or iPad or any other Android-based tab. Then every mobile or this tab is having camera over here. So once we switch on the camera, then we can see the real world. Okay. But here, we can augment the object. The object may be this particular laptop mouse, or it may be any other machinery, or whatever image or 3D model what we want to augment over there. So that's how the name of this technology is augmented reality. So in reality, we are seeing what is there around me, but I will be able to augment some object and I will be seeing as a 3D model. So that is how it is called the augmented reality. So what is the difference between augmented and virtual? Based on these devices what we have. And second thing, the experience. So in augmented reality, we may not get that immersive experience, what we are getting into virtual reality. But we can see any say type of smallest object to the largest object like a factory setup, power plant, anything in front of us in the mobile screen. So that is the augmented reality. I hope you have understood what is the difference between VR and AR. So before going ahead, if you have any doubts till this session, you can ask me or then I will move ahead. Okay, so no doubts, I will go ahead. Now, coming to hardware, that means what we are going to use. So there are different manufacturers which are available for VR headset. Like this is by Facebook. So initially it was owned by Samsung with the brand Oculus. There are different models. Oculus Rift X, Quest 1, Quest 2. Later on, before changing the Facebook name to Meta, they acquired this Samsung hardware company, that is this particular division, and they have renamed it as a Facebook or Meta. Okay? So this hardware is from Facebook. Then other available hardware in the market is the Microsoft HoloLens from Microsoft. Then third one, popular one is the HTC. So there are different models from HTC Vive and all others. Now, which one will be suitable for our academics, particularly into our engineering stream? So we have done a lot of research and we found that this Meta or the Facebook hardware is much easier, much compact, and this hardware is having the frame rate in such a way that it doesn't give a strain to your eyes over a longer duration. Longer duration, I mean to say up to 1 hour duration. So after every 1 hour, you have to take a break for 10 to 15 minutes, and that is very good for our eyes and health. So that is the recommendation. And this is very compact. So like in mobile handset, what we have all types of gyrometer, compass, magnetic compass, and other sensors what we have. So according to that, mobile is giving the data by various apps. So same kind of sensors are here which are incorporated into this device. So here what is happening, this is very compact device, and whatever we are going to experience, that should be in 1:1 scale. So like if I am in a thermodynamics lab, or if I am on a bridge, for example, at construction site, so that should appear me in 1:1 scale when I am wearing this headset. It should not be very small in dimension, or it should not be very large, whereby I will get confused. So we are trying to apply all the physics, that means all the laws of physics or whatever the different principles of physics into this particular VR modules. And we have found Facebook hardware Meta, which is metaverse ready, is very handy, compact, and very easy to use, and it doesn't require any maintenance or lot of maintenance for it. Compared to like say HoloLens, which may be a very costlier. It is primarily an HTC also, which are used into mostly in industry for R&D work or some other mixed reality projects. Compared to this Facebook or Meta Quest 2, which is the latest one, those are little bit bulky, overpriced. All right. So that is the difference when the hardware which is available in the market. Now, before showing these experiments, that means live demonstration in this VR headset, I would like to take a run through few slides. So how we are associated with various institutes like NIT Surat, for example, and we are trying on one project whereby we are converting some models from virtual lab to virtual reality lab for a better user experience. Say for example, we have created this ladder rank mechanism, which is run as an experiment into virtual lab. So there the limitations are, though you can conduct the experiment virtually, remotely, not virtually, remotely. So you have a control panel which can be downloaded into mobile handset, or it can be accessed from computer. And with changing the values, you can see the experiment it is being run physically at one place, wherever it is being located. It may be NITK or IIT, any IIT, or maybe some other institute. But supportive content which is almost there, it is into 2D form. So there is no 3D interaction over here. And so what we are trying to do, converting that into AR in mobile handset, and trying to implement the parametric solution in that. So if I change, for example, XYZ axis, how the size is going to affect, how the motion is going to affect, along with the different parameters like velocities and related parameters in that. So that's what we have just started. So we are working for almost all streams. I can show you the applications into mechanical, electrical, welding. Like welding is one of the offshoot for workshop technology. So technological point of view, any stream is not a constraint to create the content. And we will see what type of content can be created over here. Like it may be inside workshop scenario, different tools like this is lathe machine, grinding operation, fitter operation, 6-cylinder engine assembly, disassembly. Even in mechatronics, whatever complicated processes are there, those can be simplified and shown along with the instruments which are being used in our physical lab. Here is the example of scaffolding which has been used. So there is no limit what we can show, but that needs to be optimized and created into VR. And in industry, I am going to cover the practical installations where it is being done. Like say for example, AFCONS, this is Sapurji Palanji Group. So they have installed for training of their supervisors and workers, and they have benefited a lot from this. Then United Phosphorus, which is one of the biggest agrochemical company, having 40 plants worldwide. So they have also implemented a few training models in reality. So after showing the academic part in a lab, how industry is going to use it, that I will also demonstrate. But this is I'm just listing. For L&D also, we have done a lot of work, and even for L&D's training academy at Mud Island here in Mumbai, whereby all GPs and trainers from various vocational institutes are being trained. So they are using combination of our engineering online courses, some AR/VR technology, followed by the practicals and the final assessment. All right. So now I will just stop sharing this screen and try to show you the live demonstration over here. If till this point, if any of you have any queries or doubts, you can raise a hand or ask me, or otherwise I will continue to the demonstration. Okay, so I will continue with the demonstration. So I'm going to wear this headset, and whatever I will be seeing, I'm going to share on the screen, which you all will be able to see myself also what I am doing, and from other camera what is being seen on the screen. So let me share that. So I will try to pick up random models from various things, like the simplest one in mechanical engineering. Like for example, gearbox assembly. I am sharing the screen and simultaneously and performing that experiment. So I hope all of you are able to see my screen. So here this is the learning objective and list of different sub modules which are available for this experiment. Say for example, here I can see the gearbox in front of me with some parameters in front of me, and I can play this gearbox animation. Animation means I can just see how this gearbox will be working at different speeds. It may be 1x, 2x, 3x, or 4x. Now, from learning aspects, we have included a few parameters, and many other parameters can be also customized and added over here. So I can change the gear ratio. So as soon as I change the gear ratio, so the length or the size of the gears are changing, and also the related parameters which are being changed. So this can be used from application point of view also, And from design aspect also, certain key design aspects which may be difficult to explain to the students. So those can be also included as a table over here. Then cut section. So most of the time for the first year engineering students, cut sections may be a challenge for them. So in XYZ axis, I can just add or reduce the cut section. And I can have a look. Okay. So this is one of the what I can say best application to see the cut section. We can explore this also. So I can see different parts over here. I can move into any part here, okay, and I can see the inside component. I can assemble it just by click on button. So here, whatever the different components are there, I can explain. I can see the cut section. I can even see the nomenclature also with the formulae if required for design aspect. What are the major formulae which are required for design of gearbox? Then I can change here some part of gamification whereby there is per gear and helical gear. So I can just pick up the component and I can place it. Whether I am placing it correctly or not, that is the gamification part. So this is not correct. Try again. So I have to lift the helical gear, place it in front of small helical gear. I have to lift the spur gear and place it in front of the spur gear. Then it is correct. So this is a small gamification part. So like this, we can customize all the models. Let me try another demonstration. Let's say for welding. Sharing the screen. Yes. So here, this is a workshop setup for welding, and moreover, this welding experience can be available into multilingual, multiple languages, any vernacular language. So right now we have rated for in Gujarati and English. So same can
પ્રયોગ
be
નંબર 10 ગેસ કટિંગ પ્લેટ પર પરિપત્ર લક્ષ્ય MS પ્લેટ પર પરિપત્ર ગેસ કટિંગ કરવું.
So that was in Gujarati. So I have converted that language into English.
Wear PPE kit.
Here PPE. So that is the first requirement. So this is a welding workshop environment whereby I can see the gas cylinders, some tools for welding, there is a transformer, and first of all, as per industry requirement, it is being advised to wear the PPE kit first. So what are the items in the PPE kit? Like we have welding helmets, safety goggles, safety shoes, and this is a mannequin which is being seen as if I wear this, how I'm going to look. So I'm selecting these equipments, PPE kits.
Keep raw material ready as per the given drawing and dimensions.
So this is totally a guided experiment whereby initially the faculty are explaining in the classroom like what I am showing with the help of this lens and projecting it on a projector. So any student can also participate in this as if you assume me as a student and the expert or the faculty are explaining the concept and I am doing it step by step over here. So we are showing the drawing also over here for that particular experiment because drawing reading majorly is a difficult part for the most of the engineering students, maybe in the first year when they come in. So here the step number 2 is to keep the raw material ready. So I am saying these different tools. So I can interact with any of these tools, like I can pick up. So the controls are very simple. I am seeing this as my palm, these two controllers. So I can move, like I can press the middle button and I can see these palms are getting into phase. So that's how I can pick up any particular component over here in my hand, and as long as I am pressing this button, that particular object will be in my hand. So here the first step is, as per the drawing, I have to draw a radius, or then we'll draw a circle with radius 70, and the dimensions are given. So even if, like say 150 mm by 10 mm, so there is a foot scale also available over here, and all the dimensions will be as per the real world. Okay, so here, even if I try to measure the dimensions, it will be almost the same what we have physically. So now I will carry out the first step to draw a circle with the help of triangle.
Keep the job on the cutting table in a flat position.
I have to keep a job in a flat position on the cutting
Clean the
table.
job surface with a wire brush and remove burrs by filing.
So now I have to clean the job surface. So if I don't clean the job surface and try to do other activities like welding or cutting, then what are the disadvantages? That needs to be explained by the faculty or the expert. And most of the times in our workshop, we are having this setup in a ready condition, like the gas cylinders and different accessories. And we are telling the students to do the end activity. It may be different types of welding or cutting, but we are not giving them a chance in reality to do this setup physically. So that's how that is the gap. When they go into industry, they might not be aware about the different setups or the basics, what they are supposed to learn in our lab activity. So this is for welding, it may be applicable to any other practical. So here,
As per the drawing, the surfaces of the job should be marked and punched.
so the next step is to mark the job with the help of say this center punch and hammer. So whatever position I am seeing in fluorescent green color, so that is the guiding position. So I have to put my center punch aligning to that position in the green and hammer it. But if I try to hammer it like only by touching it, so I am getting a sound, but that impression is not been marked on the job. Why? Because we are trying to get the feeling or the forces which we may apply in the reality. So unless I hit it with the right force, it will not get punched. So I have to do a action, even though I am not having these tools practically, but I am feeling it that I am having this hammer and I am applying a force which is necessary in a real condition. So most of the time in workshop, the students are doing this marking not only one stroke, but let's make strokes. So we are doing marking for multiple
Tracking of both the
and damaging
cylinders.
the job. So these are the learning points whereby one participant can do as many times as he wants the practice in a correct way, even with mistakes and learning from their own mistakes. So the advantage is there is no wastage of material. There is a perfect learning, outcome-based learning, what is required at the end of this practical. Now, the next step is cracking of both cylinders. So what happens? These cylinders, if these are not cracked, that means we are just letting this gas pass out. Because if there are certain impurities before joining the hose, then it may affect our welding.
Fix regulators on both the cylinders. Fit the regulator for the right-handed thread run clockwise and left-handed thread run counterclockwise.
So the different nuances here, like one type of regulator on oxygen or acetylene, one is clockwise, having clockwise thread, other one is anti-clockwise thread, and how we have to fit it. So that is the which may not be that the student may not be aware if they don't do it themselves. So here we are saying that certain part can be done virtually.
Fix flashback arrestor and hose connector on both the
Like
regulators.
setting up cylinders, which may be a hazardous activity in real life, practical in workshop, and things which are really needed, like welding, cutting, angle, those can be done practically also after practicing in VR. The next is fixing the hose. So these are the hose pipe having different color. So I can attach it to the regulator.
Fix hose clip to avoid leakage of the gas at regulators.
Then to prevent the leakage, I have to put on the hose clips on both the pipes.
Hose connector, fix hose pipe and hose clip
Now this is
on
a
welding
welding
torch.
or gas cutting torch, and I have attached the hose connector so that I can attach the hose over here. Again, to prevent the leakage, I have to
Fix hose pipe on both the regulators.
now I can set up the gas pressure. So I can see here the readings also on the knob. So maybe through this zoom call you may not be able to see it clearly, but once you near the lens, you will be able to see all the readings over there. Now we have to check the leakage also. So again there are two aspects. One is the oxygen cylinder, one is the acetylene cylinder. Okay. So for acetylene, whether we have to check it through water or soap water, normal water or soap water. So for acetylene, we have to check it by the soap water. If any bubbles are there, then our predictions are not okay or those are incorrect. If bubbles are not there, then this is perfect. Again, with the help of water, we can change the oxygen regulator. So no bubbles. So this is a very what we can say perfect setting. What we have done. Now on this setting torch, we have to fix the cutting.
Open acetylene control valve about 1/4 and light the flame with a spark lighter.
Now since we have attached this hose from oxygen and acetylene cylinder, so first we have to open 1/4 of this wall from acetylene.
Set the gas pressure on the regulator as per nozzle size. Set pressure on regulator as 0.15 kg per square centimeter.
In this drain position, I have to get all.
Check leakage if any. Fix nozzle on welding torch.
So here on a welding plate, there is a guiding point also. Here to be taken dot and the here.
turning off flame. Now close both the gas cylinder valves.
Then I have to close the gas cylinder valve.
Open oxygen control valve slowly to get the required flame setting.
Then I have to clean the job with the help of
Experiment successfully completed.
So this is how I have completed my experiment with all steps which are required. Now maybe a couple of other experiments I would like to show you, and some visuals are also there. But meanwhile, if you have any questions, please feel free to ask me. Yeah. Any question? So participants can unmute and ask if they have questions in between. So now I will show you the other experiment.
Sir.
Yeah.
Sir, in the lab also this connectivity and the camera should be there, and it should be interconnected with the participant, those who are connecting with this device, right? If it is a live thing which we wanted to show it, especially in engineering colleges and all, if it is the classes are going online, that time one faculty can be in the lab and he can be direct. At the same time, the student can also be connected with this type of devices, right?
Absolutely. So if it is a distance, that means they are not present in campus, and if they are having this device, then they may be connected. Or for example, you are connecting through Zoom or Microsoft Teams. So faculty is in a lab, student may not be present into lab, they may be having virtual presence at home, hostel, or wherever, or maybe in classroom also. Then faculty can just connect it to our laptop or desktop, share the screen, and whatever they are doing, that can be shown it to many participants. And if they want to experience that, then they have to have their device, this device at their home, or maybe they can come into a lab in the next slot, and they can experience themselves. So they can practice. So here the advantage is whatever the process is there for say practical, maybe having 2 hours, 4 hours, or maybe an hour also. So this can be quickly done in say 15-20 minutes, because here we are not trying to do some repetitive activities, but we are trying to do activities which are really necessary from learning point of view. So,
Yeah, it's if it is in the live class, especially through online.
yeah. So online, if we are trying to explain them with the help of videos or images, they may not get that idea. But if I am doing like as in the workshop environment, like I have done right now, and I have shared the screen with you, so you can all at least can get a idea about what is happening into lab and that particular view. And this can be done with our own pace also. That means our own speed. Like if I have to understand for the first time, I may go a little bit slow. So this is up to the user. That means this is not perfectly what we can say time out. Like in case of video, it may be fast, medium speed. It can be done with our own comfort. So that is another.
Otherwise, sir, the important things can be recorded, and later on the students can be visible or watching it later within the time frame which we can set up, right?
That is also possibility. Say for example, there might be a case for one type of lab or one type of experiment. There might be 2-3 different kind of explanations which are required. So as a faculty, for this welding experiment, I can record myself 2-3 different scenarios as a video. and I can share with the students whenever they are free or live also. They can have that kind of idea. So that is a advantage with this kind of system.
Sir, in the case of field exposure, like if you are visiting an industry,
Right.
so in that cases also we can take up our laptop or iPod and connecting it with that, then students can lively watch whatever is, recording it like that. Is it okay?
That would be like showing to a camera because the asset might not be ready for that industry. So I will just come to that industrial background. So for example, you visit some industry in your respective electronics, electrical or mechanical field, and you have that recorded sessions or that particular, what you can say, machinery or process with you, and you want to recreate that same kind of experience into virtual reality, whereby student may not to visit there again and again, or it may not be feasible. So that kind of scenario can be recreated into virtual reality. So those examples also I am going to show it.
Okay, sir. Thank you.
Any other question? Like then, yeah, I think Mr. GVK Rao have raised, he has raised hand. Sir, if you have any doubt, just unmute your mic. Rao sir. All right. Meanwhile, I will just start another experiment to show it to you. So I will show you. So I have some mechanical side. Maybe I will show you electronics. Let me share the screen. So this is the electrical or electronics lab environment. So this is customizable. So for the sake of this experiment, 4-5 experiments, we have created this kind of setup. So we can change this as per your requirement. So here this is the list of experiment. I can select experiment number 1, which is the soldering.
Soldering.
Okay. So here I can see different tools which are lying on the table. Like pliers are there, sponge is there, and different this component like capacitor, transistor. Then on this table I can see the soldering rod. Some electrical sockets are there. Then safety glasses are there, and many other machineries can be also shown. But for this experiment, what is required? Those are being divided onto these 3 tables, these assets, and I can interact with them. So this is a step-by-step method. So let us see what is the step number
Wear
1.
safety glasses.
So the first condition is to wear the safety glass. I'm wearing
Place the soldering iron in its stand and plug it in. Wait for the soldering iron to heat up. A soldering iron can heat to around 400 degrees centigrade, which can burn you or start a fire. Wipe the tip of the iron on the damp sponge. This will clean the tip.
So here, after switching it on, I am seeing here the temperature. This is risen to 400 degrees. Now, wipe the tip of the iron on the damp sponge. So this is a damp sponge which is there. So here I have to first confirm the step that I have understood the step, what is to be done. And then only I will be able to do the action. So I can lift up the soldering rod and there is a highlighted position. So I have dipped into damp sponge and I can see the fuels coming out. So this was the
Place the component into the board, making sure it goes in the right way around. Bend the legs slightly to secure the part. Place the board so you can access the pads with a soldering iron.
So I can get the component over here. And place it over. And I can pick up plier, I can bend the wires. There is some line there. Let me restart it. But anyway, the steps would be like that. So I can do soldering step by step. So there are many experiments like Ohm's law is there and solenoid. So all experiments are there. And one more admin aspect like what we have done for the civil side. So maybe compressive strength of cement that I would like to show you before going to industrial application. So we are creating many more models, but these are few models which are under development.
A face mask and eye goggles before starting the experiment.
So this is the commercial testing lab. So all equipments are there in this lab. So in this corner table, here instead of iPad, I can have an arrangement to read the instruction on the wall itself in a bigger text. I can wear this.
Check all the apparatus required on the table.
So I can check the apparatus. Like this is the Tesla, grease, tapering rod. This is the mold, weighing machine. So I can just check it up before conducting the experiment.
Prepare the required number of cube molds for the experiment. Pick up the highlighted plate and place it on the highlighted place.
I can pick up the plates.
Now, pick up the screws and place them in highlighted place.
I can pick
Now,
up-
tight the screws using a spanner or wrench.
I can tighten it up.
Similarly, place the rest of the plates and screws. Using a spanner or wrench, tight them one by one.
So here, practically what steps we are going to do to set up this mold, I am doing here virtually. But I am getting the same feeling what I will be doing practically. So these screws have been tightened up once I apply the spanner over here. So here, some of the actions we have kept
Now,
it,
pick the brush
as the
and
animation.
using it, apply the grease inside of the mold.
I can pick up the brush, the grease, and apply.
Now click on the next button.
So here what is happening, I have done the process for setting up one mold, but similarly for testing as a compression testing experiment, I need to have multiple bricks or molds. So here we are trying to reduce that time by doing one activity and multiplying it or showing it multiple boxes. So that is enough experience. For
Collect
you.
and weigh the materials required for each cube separately.
Now these are the
Pick
materials.
the grade 1 sand by trowel and drop it on the weighing machine. Now pick the weighing machine tray and drop the sand on the second tray. Similarly, repeat the step of grade 1 sand for grade 2 and grade 3 sand.
So here, whatever the instructions are there, accordingly I am conducting this. Grade 3.
Now, using a trowel, pick the cement from the cement bag and drop it on the weighing machine tray.
So this is cement.
Now, pick up the weighing machine tray and drop the cement on the second. Now, dry mix the mixture using a trowel. The mixing time of dry mix should not be more than 1 minute.
So here I am mixing the cement. After mixing it,
Now, add the water in 1/3 quantity of the total required water.
so I can see the quantity of water over here also. I am pouring the water.
Now, mix the mixture with water.
To mix. So practically whatever steps I am going to do, that steps I am following over here. I am getting the same feeling like this is a mixture.
Add the next 1/3 amount of water. Again, mix the mixture with water. Now add the rest of 1/3 amount of water.
So in between, like if I am doing for the second time or third time for practice, if I
Again,
click next,
mix the mixture
then I can
with
do this
water.
step also. I can jump to any particular step anytime.
Now click on the next button. Pick up the cube mold and place it in highlighted place.
So here I will go a little bit backward because this is in 1:1 scale. So whatever that will thing which are placed on ground, I have to really bend and get it done. So I'm placing this box.
Now, tight the highlighted lock of the mold. Pick the mold assembly and place it on the vibrating machine at the highlighted. Now tight the highlighted screws of the vibrating machine by hand.
I'm tightening it.
Using a trowel, pick the cement mortar paste from the tray and place it in the highlighted mold 2 times. Now hold the tamping rod and tap the mortar paste. Similarly, again insert the mortar paste and tap it. Do this 2 times.
So as per instruction, I'm just following the steps.
Now, place all the cubes in water tank for water curing.
So here I am putting the cubes. In a water tank for curing. So okay. Now the next.
Take out the 3 cubes from the water tank for 3 days of testing.
So we assume that 3 days have passed, and now we are taking the cube. So 3 different cubes I am taking it out.
Leave the cube for air dry for 1 hour before testing in CTM.
So practically, the setting time and soaking time, which is very that means longer duration, and longer duration. So this we can assume over here that can be done very quickly, and we can conduct the experiment. And we have already put in the probable outputs over here. Sorry. So I have come out of that experiment. So like this, we can build the lab experiments for civil, electrical, mechanical, or any other stream, wherever we have actual lab setups that can be mimicked into VR setup, or the other case whereby day by day the technology is advancing and the new setups which may be costly or the industrial scenarios where we are not able to go and show it to the students or experience that. So those can be really built in into VR. So we are saying the setup which may not be possible to upgrade or to bring it into the labs or in classroom, those can be created into VR, and the rest of the practice students must do in the lab. Now I will just give you few industrial applications here. Like say we have done for AFCONs. Like I have shown that image in the PPT. Let me share the screen. So this is the environment what we have created. So the experiment is getting loaded. So there is a express highway Mumbai Nagpur which is and I can uh, this was the scenario which has been created for AFCONs, whereby initial case was they have to train their workers or supervisors after the erection is done at the site. But because of this training model, what happened? They were able to train their workers beforehand, before erection is happening, and they have reduced their cycle time from 19 days of construction of one girder to 12 days. And workforce also required is reduced from 50 to say around 35 to 40 in that range. So there is tremendous cost saving in multi-crore projects. So this is a practical application. And like this, I have many other applications. So maybe instead of showing as particular what you can say as a demonstration, I have some recorded videos which I can share. So maybe a couple of videos I will show it to you, and we can proceed for question and answer session. Yes. Say for example, fire safety. Let me share the screen. So this is a general fire safety scenario whereby we have created different types of fires like electrical, chemical, and general fire. And experiment is all about to select the correct extinguisher, like it may be a CO2, AFFF, or ABC, and the different steps. How to remove the pin, how to turn the knob, what should be the distance from the fire, and how to extinguish that fire. So in case of electrical fire, it is so whatever parameters are necessary, like pressure of the cylinder, how much time it will be there, that particular mixture, and whether that will which flow is the electrical switch first. So these are the scenarios which have been covered over here. Like in case of normal fire, so there is a methodology. So in case of fire drill, even in as of today, in maybe any commercial space, office space, or even in our university or colleges, so it is happening maybe once or twice in a year, and all of us are not attending the same. We are just seeing that demonstration by that equipment provider like this extinguisher. So here we will get a chance that each and everyone, it may be a old person also, a small child also, without creating the fire and experiencing the same thing and making awareness. So this is one of the generalized models which is applicable to not only in industry but in our day-to-day life as well. Then one more video I would like to show you. about chemical industry, what we have done. So like what I have shown in the slide, United Phosphorus Limited, which is one of the fourth largest agrochemical company. So at one of their plant in Gujarat, they were having training issues for working in the confined space in a chemical reactor. So here the situation was, you can see a chemical reactor and agitator shaft. So one of the blade is been broken, and now the scenario is, with along with safety precautions, we have to replace that blade. So generally, to replace this blade, as a layman, we can think of maybe 4-5 steps. That worker can go inside the that particular confined space with the tools, remove the blade, replace it with the new one, and come out. Only these steps we can imagine. But if we see the standard operating procedures of that particular industry, especially chemical one. So here you may not be able to see clearly the forms. So it will start with the permit form selection, like which is the correct one. So actual forms which are being used into industry, those are being shown over here. Then the reactor is being switched off and it is been locked so that other person cannot come and accidentally start that reactor from here. And the key of that lock is been put into login tag, logout tagout box, logo box, which is been again signed by the user officer and locked. So then after that, the worker will go to the actual place. He will again check whether it is really switch off or not, that particular reactor. Then next, the blinding of the chemical pipeline. So blinding can be done with the help of plates. In case of nitrogen, it should be totally removed because there were many accidents which have happened due to excess quantity of the nitrogen in the confined space, and there were many deaths which have happened in the field. So after this, we are cleaning the reactor. Then physical inspection, whether any gas fuels are there. If gas fuels are there, we have to clean it with the help of jet of water. Then we have to check the gas level with the help of gas level meter. So unless those are in a acceptable condition or safe level, we cannot enter into that. Before entering, we have to again wear the PPE kit, wear the bubble hood for oxygen supply, sign a final permit form, enter into the space, confined space, reactor. But here they have given one situation, like in case of emergency, if the alarm goes off, so worker have to leave their current work aside and they have to go to the refugee area outside, wherever it is there nearby there. So that is also one of the scenarios which we have created. So after this, the worker changes the blade and comes out. So this is the total, what I can say, training module what we have created for UPL, United Phosphorus Limited. So similarly, there are many other modules where we are working with the industry. And so coming back, if we implement this, we are teaching pedagogy in our day-to-day teaching for various labs, for various category A concepts. And again, if we map the requirement from industry also, so what they are expecting from the students, then I think it will be really helpful to achieve our objects. That is, first, it will be outcome based. Outcomes will be as per our expectation from the students. It will help them for what we can say, employability aspect also, employability angle. And for some institutes, what we have seen in Rajkot side, whereby there is small industry across, the institute themselves, their faculty, with the help of some outside experts, they are trying to get the projects from the industry and exhibit in the environment what they have in the college. So they are even one step ahead that how to use the college infrastructure for the industrial consultancy. So these are the different benefits what we can see, and it's very easy to adopt this kind of pedagogy, and it is not a very tough task. So maybe at the end of this session, I would like to show you few videos for certain excitement which is seen in the users during our various events or wherever we have given this particular solution. So I would like to play few videos for that to just make you aware. So how excited the end users or the people are.
Excuse me, sir.
Yeah.
Sir, with this piece software, can we make our own video, our own specific videos? Is there any provision to make it?
Means I didn't get your question. Video means for this meeting you are saying, or for our
And now you are showing, which is already made by somebody. See, for example, if we wanted to make by ourselves with our own requirement, is there any specific software with some pictures and other things which we can take it and we can create our own videos for our own purposes?
Yeah, ma'am. So that is definitely doable, and you can contact us for your customer requirement, and we will suggest the required.
That software we have to buy it, or it is available free of cost for a period of time, or how is it?
No, ma'am. There are two components over here. One is the hardware, that is one laptop along with this lens. And second part is the software part, like models, what I am showing it to you, like electrical or mechanical or industry applications. So those whatever are available, those can be utilized readily. Few other customization, like you said, those will be created by us for you.
For
Specifically,
customize our own,
yes, yes,
whatever the existing, which with that we can customize it.
absolutely.
What is the cost of this device, sir?
So the hardware cost for this Meta Quest 2 is in the range of 35,000 to 40,000. It keeps changing, but this is the cost along with this two controller. And this will require, say, for example, the industry experiment, what I was showing it to you. So it is all about 3D models which have been rendered in a live situation. So it requires a processing power, graphic card. So for that purpose, you will require a laptop, say in the range of 1.2 to 1.4 lakhs rupees, the average one, mid-level one, not very high end. So the overall cost of the hardware will be in the range of 1.8 lakhs to 2 lakhs rupees. And depending on your supplier, so we are not into hardware business. So we can give you specifications and you can buy from your own hardware supplier also, so that you can get some cost benefit. And
The
yeah.
computer should be compacted with this particular software, or in our own computer it can be installed, or
No, we will give you specifications. For example, I will give examples. Computer, it will be a desktop or it may be a laptop. So few minimum hardware components are required. For example, i7 processor. It should be having graphic card, say example 3060 ITX minimum or above that, and having the RAM of say 16 GB minimum. So if these 3-4 components are already there with you, then there is no need to go for extra hardware. If it is not there and you can customize it, or you can, if you don't have, you can buy it. So that is your decision. That we can just give you all these guidelines. Or if you want us to set up the complete lab with 5 devices at your institute, then we are ready to do that also.
okay, thank you.
And the software part, the experiment what we are showing, so those are on subscription basis. So that will be a really affordable cost as far as what. And here also, one point I would like to mention that all the content for that particular subject or the lab may not be into VR because we have to categorize the content into category A, category B, category C. So category A is the most difficult part for imagination, for limitations like practical availability or the cost of operation or maybe some hazards which may be involved. So those kind of experiments or ideas or the concepts can be created to that means on a first hand in VR. Then category B, which are the mid-level difficulty. So that can be also created. But category C, which are like theoretical aspects, definitions, or very easy with the help of AR and mobile, with a few models and faculty explanation. So those may not be created into VR. So that will optimize the cost of your investment and also the delivery for the students if we mix all these things together. Any other question? So maybe I will show you this video. Share the screen.
All three different experiments for three samples.
So just couple of days back, we had this event at Parul University, Vadodara, whereby AICT Chairman Dr. Srmist, ISRO, that Western Region ISRO head,
Dr. Nilesh Desai.
Dr. Nilesh Desai.
He is ISRO Ahmedabad head.
Yeah, so those are seen. So they have visited our setup. He is the Dean, Mr. Dr. Venkaria, and principal of that Parul Engineering College, who has explained that. Then these are few students. So even if you see, students are doing for the first time, but you see how fast they are doing. So that girl is doing the 6-cylinder disassembly of engine, car engine. So the students are very quick to learn these new concepts and they can really apply their mind. He is Dr. Mewara.
He is principal of Parul Institute of Technology.
And these are the views by one of the professors.
From automobile department of Parul University. Just now I have experienced the VR technology in which I have gone through the disassembly of IC engine, and I feel like that yes, students can learn disassembly and assembly of IC engine very safely. I want to add one word, safely, because initially as we know that if we are not that much skilled, then during working in workshop it may create some kind of accident. So we can avoid such type of accident, as well as at the same time we can develop the skill of the students also, as I feel right now by going through that disassembly of engine. Students can aware about each and every components, parts, nuts, even each and every instructions are there that you have to use this particular tool for going to learn each and everything, types of tools, where that particular types.
અને પછી આપણે જે એક્સપેરિમેન્ટ જોયો એ એક્સપેરિમેન્ટ દ્વારા આપણું વ્યૂ how it is useful to faculty for teaching and students to
and we are spending time to visualize the thing, we are explaining the things and But now I seen the demo of this virtual reality from the Fist Software Private Limited. In that I seen the demo of workshop, I seen the demo of the bridge which is constructed virtually. So in that I seen the experience and I feel the experience using the virtual reality. Whatever we are going to perform practically, before that some virtual things would be able to see and how it is going to when physical construction. So it is a one type of prototype, and that prototype will be the interactive. Now people are preparing the project as a prototype, but prototype is not serving as interactive. But this prototype is with the interaction, with the dimension, with the depth, with the height, everything you can measure using the virtual reality, and this would be benefited to the students when they are going for the practical approach. So this is really good experience for me, and in using this, the lots of work of the teacher and students would be easy for the practical hands-on session. So I suggest all the teachers and students to see this demo, and it would be possible then go with this software and virtual reality. Thank you.
We are looking ahead for a net association with CU.
Sure.
And
Sure. So we will look further, and 100% we will try to, we can say, installations of these things at our university.
Thank you very much, sir. So encouraging.
So these are a few others, like students. So this is one of the Vidyanagar Diploma College in Mumbai. So you can see the excitement between students and how fast they pick up. Then so one more interesting thing. So I happened to go to one of the ITI in Karamsad,
Near Gujarat.
Gujarat in Anand. So here this student, what we are seeing, he is deaf and dumb. So he's not able to hear and not able to speak. So I was just showing him with the help of gestures what to be done. So I'm wearing him the headset, and within few seconds he started doing this thing on his own because all instructions were there. So at least he was trying to read or feel that particular setup. So that is the what we can say, the power of technology which can be seen. So the student is deaf and dumb, but still is performing the welding electrical experiment he was trying. Yeah, so this was again physically challenged student who has also performed it very well. So VR is a tool without any limitations. That's what I can say. So any person can, like irrespective of age, irrespective of maybe at some extent physical condition, they can do it very well. So these are this is the group from Don Bosco, sorry, KJ Somaya. So they were experiencing this at our office. Then this is one of the safety experts, level 6 and above. So who is making your fire and even say for example, this is he is from Markson Pharma.
ट्यूशन डिपार्टमेंट, और मैंने अभी रिसेंट जो है फायर फाइटर का यहाँ पे एक डेमो दिखा है, और उस डेमो में
3D मूवी में था और जो कि बहुत ही हेल्पफुल है, क्योंकि सबको हम अगर देते हैं तो ट्रेनिंग देते हैं, लेकिन उसमें विजुअल दिखा नहीं पाते हैं। एक्चुअली फायर उतना लगना भी नहीं चाहिए, लेकिन फ़िलहाल में यहाँ पे डेमो में वो फायर लगता है और हमको बुझाने का मौका मिलता है। तो उस सिचुएशन में पर्टिकुलर हर आदमी को ऐसा ट्रेनिंग दे के हम बता सकते हैं कि इस सिचुएशन में कैसे हैंडल करना है। हर एक आदमी उसमें क्या होता है, फायर फाइटर बन के उसका जो फायर एक्सटिंग्विशर है उसका पिन को पुल करना, प्रॉपर पोजीशन पे उसको फायर को बुझाना, ये सब करके देखता है। लेकिन मुझे अभी इसमें क्या है कि जैसे डिफरेंट केमिकल सॉल्वेंट होते हैं जो कि पर्टिकुलर एक टाइम पर उनको रखना या फिर स्टोर करना पॉसिबल नहीं होता है। तो अगर इसमें आइटम देखेगा तो अच्छा रहेगा कि सॉलिड और लिक्विड केमिकल को सेपरेट कैसे रखना है। बाकी फायर डिफरेंट टाइप के होते हैं, जैसे इलेक्ट्रिकल फायर हो गया, उसके बाद आपका केमिकल फायर हो गया, और कब किस जगह पे कौन सा फायर गैस यूज़ करना चाहिए। सपोज़ ड्राई पाउडर इंस्ट्रूमेंट में नहीं मार सकते, उसके बाद बालू सैंड हो गया, उसको हम किसी इंस्ट्रूमेंट में नहीं मार सकते, और ऑर्गन कार्बन मोनोऑक्साइड कहाँ मार सकते हैं, किस पोजीशन, ये थोड़ा और उसमें इलेबोरेट होगा तो लर्नर के लिए।
This participant was trying to explain about what we have done for fire. Now at one of the event in Bhopal, I said
मूवमेंट के बारे में पता चलेगा, कैसे पता चलेगा सिर्फ जिंदगी में तमन्ना रखते हैं कि हम ऐसा
complete disassembly of the engine. He was so interested, he completed in say 15-20 minutes, half an hour, that disassembly of engine with more than 100 steps. So this particular person. Okay. So this is the disassembly what we were doing. And again, later on, out of interest, he performed few industrial models also. Very efficient. So if you see, there are a lot of what we can say excitement among the faculty and the students across India, wherever we have gone, and many institutes we have implemented also this group. So for example, this is a faculty at Don Bosco ITI in Mumbai. So they are teaching with the help of this AR/VR pedagogy. So here the institutes or the faculty who are using this, they are telling us on their own that after using this, first of all, they were able to complete that particular concept explanation within the stipulated time. And immersive experience, due to immersive experience, the students, some of the students who were giving not that attention to that experiment or that particular topic, suddenly the view changed and all of them are very interested to perform this practical. And it gave the required, that means expected output out of that student. So I will show you a few other videos also, like how this is been implemented at Anil Naik Technical Training Center at Kharel. So this Anil Naik Technical Training Center, that means before going forward, is set up by Dr. A.M. Naik, who is the chairman of NSDC and group chairman of LNT. So he is running this center at near Navsari, Gujarat, at Kharel, which is the place, out of CSR initiative. So when we showed this to him at LNT Mart, so I will show you that clip also to you. So a year back we showed this technology to Dr. A.M. Naik at LNT Mart Training Center with this little old type of headset, Oculus Rift S. So he was impressed so much that he said out of that means that I want to implement into all 14,000 skill centers. So it was his wish. But first I will try to implement it at my own technical training center. So that's what we have done over here. And now this is the will be the use. So here faculty has taught the concept theoretically in the classroom. So in workshop, without putting more time. So the first the student is coming over here. Like previously there was a question that we have to attach this to a computer screen or the projector in a workshop. So that's what they have done. They have attached to the one of the PC screen over here. The student is doing practical first in VR. Other students are seeing, and then after his turn, the student is going for the actual practice. So with this methodology, the amount of skill which is required for that particular job is phenomenal.
சரி நானும் கவனிக்காம போயிட்டேன் அதான் மாத்தினோன்னா நினைச்சேன் ஒரு 500 கொடுத்தேன் 200 கொடுத்தேன் பார்க்காம வாங்கிட்டீங்களா
Here also, like from the first batch, he is a student named Milan Patel, who was that 9th fail. Because in this is a CSR initiative, they are taking 8, 9, 10 fail students around the vicinity of their center, training them to make them self-sufficient. So this guy, he not only practiced the welding, what he opted as a trade, but he practiced few industrial models also over there, and he was very fascinated by this technology, and he taken full advantage during his 3 months training at this institute. And finally, we came to know that he's been placed into one of the company in Qatar, Middle East, having salary in the range of say 75,000. So we were very happy after knowing this, that with use of technology and some practice at the workshop and the right approach of pedagogy which has been adopted by the center, they are really able to see the output and say employability angle also at the end of the training. So one more video I would like to show you about, say, most of you have seen the mason, like setting up a wall and all this thing. But as a civil engineer, how many of the students are actually doing it, except learning it only theoretically in a classroom or seeing it as a video? Okay. So here we have created this setup for different types of bonds, like T bond, L bond, Flemish bond, to set up a wall. So first of all, the user has to select the right tools for that particular job. So again, here the spirit level means there will be a level as per the current angle what I am holding that. So all physics has been implemented over here. So that's how it is giving us 99% reality, even though we are in virtual world. Now the first step is to stocking up of bricks for say 12 hours. So again, we have to see the bricks, whether those are broken or intact. So we have to select the bricks. So these are the small points which we can get practice here itself in a classroom or in our lab without investing into material. Okay. So here the next step is to get the sand and the cement in a particular ratio. Say for example 5:1. So again in the previous experiment what I have shown in the compression test, that we have to take a sand in a particular proportion, mix with the cement, with the trowel, pour the water. So here we are trying to keep the difficult aspects from our coding point of view, like showing the water, then this texture of the sand grains or the cement. This is very difficult and very heavy, what we can say, portion which is taking as far as processing is concerned for our graphics card. So we are trying to optimize that in a such a way that with the minimum RAM, you will be able to perform all these activities. So that is our backend R&D, what we are doing. So just to see, it is very simple, like water particles or the grain particles, but this may be into millions or billions of particles which we need to handle from coding point of view. So that is the expertise which is being done by experts or the company like us, and the concept or the SME, or the practicals maybe from institute side or the industry side. Here the next step is to to do the marking. So here literally the user has to sit on a floor and he has to do the marking. So it is not like that I am sitting in a chair or standing at one position and I am doing this practical. It is 1:1 scale. So practically what the workman doing, that we have to perform even though wearing this virtual headset. So that's the beauty of it. So that gives you around 99% reality. Along with other effects what we have. So like practically what we do, we place the bricks at two ends. We tie a rope. Then again we place the brick. For this type of bond, we need to have certain bricks into made into halves. We have to do half section of the brick. Now, how to place it to make it the T bond? So that is the practical aspect what we are going to do over here. So, like first step, we have to place the mortar on the ground. Then we have to place a brick on that. So here, how we are trying to optimize the time and processing power of this experiment. Like for example, whatever the minimum steps or the necessary know-how technically for that particular step, only that we are doing for say first time. So we are placing brick number 1, brick number 2, then we are inserting the mortar into that. Then automatically it is been shown that all other bricks are been placed. So that's how we are trying to optimize the experiment and trying to save the processing power of the equipment. Now the next thing, the horizontal brick. So couple of bricks we have placed. Put the mortar in that, and automatically that layer is been completed. So same thing for the layer number 2 or the above brick line, above that. Then where we have to put that half brick, that we will also explain over there. So there we can include the voice instruction also, or the voice explanation also along with this. So for example, students are doing on their own, then they can read the instruction and they can listen to that also. Now, as far as practical is concerned, so here we can take up rod and we can level it out. Okay, so what we are doing practically, the same thing we have to do over here. Next part is the water level. So actually what we are doing with the help of water level to check the level, whether the level is correct or not. So same physics is applied over here, and we can literally see the water level up and down. So we are checking with the help of spirit level also over here. So since we have applied the physics over here, so that's how it is giving us the real feeling along with visuals. Because for engineering, precision is must. It may not be only a practice without any precision. So 1 centimeter or 1 inch is the reality. It should also appear the same thing over there in virtual experiment. So that's how we are coding it, we are optimizing it with our own R&D, and user is getting the ultimate experience, what is needed. One more thing, the plumb bob, whereby the gravity plays a role. So that also we have coded over here in such a way it will behave like it is behaving in a physical world. This plumb bob. So I'm just trying to give you a flavor, like what are the different things, minor things, major things, which I'm trying to show you so that you can get an idea or you can think yourself in your respective subjects or fields, which are the great difficulty topics and how I can just create a VR. So at least you can give us idea and we can get it created for you. Okay. So this was one of the experiments. Meanwhile, again, I will just repeat. If you have any doubts or queries or suggestions, you can just unmute the mic and talk to me. In that time, I will show you this one of the interesting welding experiment, T-joint. So what I have shown you was only a small part. Like I shown you that we have to take a foot scale, we have to do the measuring, we have to do the marking, then we have to do the punching. So all realistic things are there. And with the same force, what is required in the reality. Same thing for the other plate. Now we are the PP. Now we have on that gas. Here on a bench wise, we have to fix the job that plate. Take a cut. As per our marking. So again, the rate of cut, the rate of the distance between that rate, that will matter. So now we have to file that. So again, which type of file, flat file, round file, half round, which needs to be selected, and how to hold that file in two hands. So that it should be a perpendicular, what we can say, filing action. It should not be tilted at any of the angles, forward or backward. So all these minor details we have tried to cover over. Then we have to place that job on a table, do the final marking for T-joint. Now the most important thing that we have to adjust the current and voltage for that particular job depending on what is the diameter of the wire, what type of torch we are using. So for example, this is a TIG welding. For MIG welding, the setting may be different. For GMAW, SMAW, the setting may be different. So with filler rod, without filler rod. So initially we have to tag the two ends. So these are the small things which are really what we can say necessary for a student to understand. And again, if you see over here in the red label, if something is wrong, like angle is wrong, the speed is wrong, or that position is wrong, then immediately there will be a problem that your this particular parameter is wrong. So that there is a chance for the user to do a mistake and learn from their own mistake also while doing this practical. And again, there will be no material wastage, no hazard. It will be within this time. and all effects will be as per our actual. So here next thing again, the adjustment of this pressure regulator cylinder. And now we have achieved the level, like most of the institutes are opting for the physical welding simulator, which is costing say around say 15 lakhs to 25 lakhs. So what is welding simulator do? AR based or VR based welding simulator, they have a physical welding gun with you, and student is doing on a job. That means there will be a plastic plate, but by wearing this AR headset or VR headset or screen, we'll be able to see the flame. And it is giving output only for limited number of scenarios, say 10 to 15, for only a couple of types of welding like GMW or TIG. And it is giving the measurement for 3 parameters. One is the angle of the torch. Second one is the distance between the job and your welding rod. And the third one will be the speed at which you are doing the welding, whether that deposition is correct or not. So all these things are being, only these 3 things are being done in the welding simulator, physical welding simulator. So same thing we have applied in our virtual reality, whereby you need not to spend that 25 lakhs and above for only one setup, which is very stationary, and limited operations are there. Only 2-3 parameters are being measured in that. So all these things can be done in our virtual reality headset. So we can the latest development in the last week that we can see all the 3 parameters over here, that your angle, your travel speed, and your distance. And according to that, if you see the job horizontally at the level of your eye, you will be able to see the depositions, whether it is less or excess. Wherever it has been, the speed is not correct, it is either burnt in yellow color. So like a physical welding, you can see all these things. So you will not need to go for the welding simulator only for this kind of thing. And in one device, here in one device, you can include multiple trades also, like mechanical, civil, electrical. So this is very high end technology with very affordable initial cost and running cost as well. So that's what I can say from my experience of the customers who are already got this particular setup in their respective colleges. So there are many other videos or applications to show you. But meanwhile, again, I will ask the audience if you have any queries or doubts, or if you want me to show some more content in your respective field, say for example, automobile or other, then I will be able to show that according to your wish right now. So participants can just talk if they have any doubts, or they can tell me what content you would like to see more apart from what I have shown. So I will be happy if you can tell me what is your expectation to see as an application. Or you can type in your chat box also.
13 messages.
Okay, so till the time you come back to me, I would like to show you maybe something more about say, automobile disassembly engine, 6-cylinder disassembly of an engine. This is a very fantastic thing to do in VR. So let me play that video for you. Or even I myself can do that for you. Let me share the screen. I hope you are able to see the lab environment over here. So I am in this automobile lab. So this is having the setup like these are the different tools which are available on the table. Right from electric, panels, bearing cooler, and mallet hammer, lot many others. And also I can see a screw container or oil bar or different kind of boxes over here on the table. Because as per world skill competition, the student or the participant, he did not to only disassemble the engine, but he has to put the components at the right place also. So that is what the expectation from world skill competition, apart from doing it in a lab. So here I can start an experiment with this assembly of engine confirm. So step number 1 is remove the underlying. So one more thing that before starting this experiment, this is the complete engine what I can see, but I can move inside this engine and see the internal components also. So right now this is stationary, so I can see the wall springs, different walls, piston, all these things. But if I started moving in the next stage, so while working condition also I can see the actual moving parts inside the engine. So now, right now, the aim of this experiment is this assembly of the engine. So I will take out the igniter coil one by one. Coil number 1. So I can put it at the highlighted place on the table. Coil number 2. Igniter coil number 3. So once I have placed that on this table, it will automatically go to this table to save the time from one table to another table, because ultimate learning outcome is how to remove this coil and place it at the appropriate place, which will be placed ultimately on a larger table. Next step is to remove the tappet screw. So here I have to take a 10 mm ring spanner, rotate it 6 times, take it out, and I can see a bolt over here. So I have to take it down in the box. Now there are two options for me. So there are 8 different bolts which are available. So I can remove it one by one, or I can click on the skip button, whereby all these bolts with a similar activity can be removed and those can be seen in a tray over there. So what are the repetitive activities are there which I don't want to do, I can just skip that. Now, next, I have removed the cover. I am using the scraper. Now this gasket, which is not usable, reusable, I am putting it in a dustbin. Now remove the igniter coil on the other side, same process. So I will skip that. Now the main part, how to remove the pulley. So with the help of this joystick, I am just adjusting the angle and I am moving forward or backward. So here I have to take the 12 mm socket, put it on a Tommy bar and place it at the pulley and rotate it for 5 times. After that, I can take out the main board. And next step, I have to remove the washer over here and remove the main pulley bearing. So to remove the bearing, I need to put on bearing to the attach the T spanner, rotate it, take it out, and then remove the pulley. Now the next step, remove the woodruff key that I have removed. Next step, crankshaft oil seal. With the help of crankshaft seal remover. So I have to attach another part over here. Put this assembly, pull it, so the bearing will come out. Crankshaft oil seal will come out, and I can put it on the table. So similarly, next thing I have to dismantle the other components. So I am putting the T spanner over here, which is rotating automatically. Okay, I can take out the bolt. For similar activity, I can skip. Now I have to take out this cover. So I have to use the mallet hammer, and at 3 locations I have to hammer it so that this cover will come out. So which are the 3 locations? That is the job of a trainer or a tutor to tell the students. Again, I have to remove the gasket. Now I have to insert the pin, put on the spanner, rotate it, and take out the bolts. So like in front of you, I have done this few steps very quickly. So like this 100 and more than 100 steps, like around 110 steps can be done very quickly with the help of this. So yeah, so these were the various, what we can say, applications what I was showing it to all of you along with the user feedback also. So if you have any more questions, then I will be happy to answer that. But as far as the content was concerned, so this was it from my side for the today's session. I will be happy to listen to your feedback or your views also on the same. What do you feel? How it can be implemented? And what are your ideas?
Dear participants, the experts are ready to answer any of your queries. If you have anything, you can raise.
Or maybe your plain views also. How do you like?
Yes, if there is any participant who can give your opinions about the capabilities of AR VR teaching, you can unmute yourself and you can give your opinions. Please voice out your opinions, please. Sir, Nitin sir, I request you to, in case if anyone wants to have a personal chat with you, you can post it here on your chat box also. They can have a personal one-to-one interaction with you. And maybe the same way people might have their questions in their mind, but don't want to open it in on forum. Shall we take it in that way, sir? Because everyone has that questions in their mind, like how these things are done, how unless they witness something physically with their touch, they will not realize the importance of what the piece has done.
Really happy to showcase this to the participants and their respective institutes.
Okay, so in that case, I will share your details with the participants. Okay, so if they have any other queries, they can reach you out. And maybe with this, we'll call it for the day, sir. I should thank Mr. Ghanshyam for his. I could not see him looking tired. He was so enthusiastic in delivering the contents. And thank you for that, sir. And Nitin, sir, as usual, you are young in your mind.
Thank you very much.
Sure, sir. And thank you so much for delivering this session for continuous 3 hours. And hopefully this might have impacted some of the participants, but unfortunately they are not in a position to speak.
Right.
But definitely you could find some of them maybe contacting you.
Yes, sir. No,
Definitely. So
most welcome anytime.
yes, sir. And thank you so much, sir, for both of you.
Thank you very much.
And convey my thanks to your Paleja sir also.
Yes, sir. Sure, sir. I'll do that.
Thank you so much, sir.
Thank you very much.
Yeah. Thanks for your work. And Yoganand sir and Srmist, we are very thankful to giving us this opportunity to present AR/VR solution and upcoming trends. And I hope to see most of you at your institute maybe in near future. So I have shared my contact details also in the chat box. So please feel free to contact us at any point of time.
Thank you, sir. Thank you, sir. And we will also share your details.
Sure. Thank you. Bye.
Okay, sir. Bye, sir. Participant, the feedback is now posted in chat box. You can fill up your feedbacks.